Welcome to our backyard. This is the Backyard Philosophy Podcast. We are two friends having a discussion after everyone else has passed out or gone to bed. Grab a drink and listen as we discuss everything from automation, space exploration, and why the meaning of life is 42.
Welcome back to Backyard Philosophy with episode 3. We're going to be talking about mining in space. I'm your host, Mike, joined by my co-host, Nick. And Nick, I got to say, I'm in love with space, and I'm so excited to talk about mining in space. There's asteroids, planets, moons, so many problems, so many solutions. We are truly living in the future. Now, for those unfamiliar with mining in space, there is an abundance of resources ranging from metals such as platinum and gold, all the way to frozen water, all the way to different silicas to make super materials. Space is just filled with opportunity. And as we progress through time, the closer and closer we get to reaching those goals. And I want to start off the podcast by reading a quote by Carl Sagan. Imagination will often carry us to worlds that never were. But without it, we go nowhere. So Nick, how are you doing?
I'm doing pretty good. It's a huge change for me to learn about a place that, with the absence of life. I spend most of my time working in a place with an abundance of it, but it's always good to try something new.
Yes, this is a little bit 180, and you're now in my world, and I am excited to talk about it. There's just so many avenues and so much to talk about. I gotta say, I just want to start off by saying awesome for Elon Musk for making reusable rockets, and awesome for NASA for decades and decades of doing amazing work. And I love how the space race is now becoming privatized and companies are competing for it. It's now backyard scientists reaching for the stars.
Yeah, and that's what I enjoyed about it. I enjoyed learning about all these different companies working with the government and some by themselves all over the world, but just like normal, I enjoyed hearing about America leading the way, even though it does kind of seem like we're in almost a space race with China to start mining in space, from what I read.
Yeah, it's a little bit of a more Cold War feeling, but I think collectively as a whole, we all realize that the future is outwards, not inwards. And America is definitely taking a big league. So is Japan. I definitely want to talk about the Habushi Japan mission that sampled an asteroid not too long ago. I think it was in 2010 or 12, somewhere around there. Within the past decade, just lots of companies like Space, which is a company that makes stuff in space. I believe they have a 3D printer on the International Space Station, which is having 3D printers in space is completely changing the game and leaving avenues to create new things. There are products that you can't make here on Earth because microgravity and having no gravity allows us to create different structures and make different materials that we wouldn't be able to do here on Earth.
And so we're going to talk about how to get those materials today.
Yes, we are. I actually want to start off by talking about the moon. Let's start a little bit close to home. So we've been to the moon before, and we've had probes go up there multiple times, and the great thing about moon is it's lower gravity, so once we get out of Earth's orbit, we could use that as a base, and it already has frozen water. Now, the great thing about having frozen water is it's not the hardest to unfreeze and evaporate the water to make it drinkable water or fuel by splitting it into hydrogen and oxygen for rocket fuel. So perhaps the first step to mining the asteroids and planets is making a base on the moon, which countries such as the United States, China, Japan, some European countries are already starting to do.
Yeah, that's one of the things I thought was crazy, and just how awesome that would be if there's a settlement on the moon. And it seems like one of the big problems that we're working with on that is just how humans react in low gravity, and learning about that and seeing that it might be more of an almost automated settlement than a human settled one.
Oh, absolutely. For those who don't know, long exposures with no gravity, you'll start to lose bone density, which can cause muscle fatigue because you simply don't need your bones and muscles to do as much work because there's less friction, less force on you because there's no gravity. We do have some counterbalance to fight off that, which is exercises. I know lots of astronauts are required to do, I think, 1 to 2 hours of exercise in space a day to combat the effects of little to no gravity. But as Nick said, automation seems to be the way of the future. Having robots go into these dangerous places that humans would have to train for, be prepared for, and bring supplies for. Just have the robots go there and have them do the work without having the risk of losing human life.
Yeah, and another thing I read is that astronauts coming back from the space station have had a reduction in vision. It's just we don't completely understand the effects of low gravity has on the human body, but as we learn more and more, all this research that we're doing now is going to pay off later in being able to counteract that.
Oh, absolutely. This might be getting a little hard ahead in the podcast, but we are already using spectrometers and other equipment to estimate how much material and how much that material is worth on different asteroids. Like, for one example, one that blew my mind, like I had no idea some of these asteroids were worth this much, was one asteroid was measured to be worth $700 quintillion. That's with a Q. That's a lot of money. Now, before we get too far and start talking about the economics, I want to bring it back to what Nick was talking about, which is polar ice caps on the moon and processes of removing frozen water and making it usable. Nick, how about you tell me about what you know, and then I'll jump in with what knowledge I know.
Well, I think what I read is there's a few different companies trying to figure that out, how to do it. And what I thought was most interesting is that we don't have a complete understanding of who gets it once you get there, and so it's kind of like a race to complete it. But what I thought was crazy is just all the different ways that it could be used. Like you mentioned fuel, and you mentioned water, and just I was just kind of figure out how do we decide once we harvest it, just what to use it for, and who makes that decision.
Well, the great thing about space, at least from what I know, is, like, especially for the moon, is no country is allowed to own the moon. And from what I've read on U.S. law, is anything you mine in space is your property. So it is a bit privatized. Now, I don't know about other countries, what their rules and regulations are, but I know for U.S., if I made a rocket, flew to an asteroid, mined all the gold and platinum and iron and cobalt out of it, and brought it back, it's my property. I can sell it. I do know, though, that with future endeavors, we're trying to switch from a hydrogen-oxygen fuel to ion engines, or at least trying to. I know of a female scientist, I think she's like 33, very young in the industry, completely changing the game by making small ion engines that are extremely well and extremely efficient. And hopefully that'll get us away from using hydrogen and oxygen as a fuel, which will make it cheaper to use in space, which means that water can be used to help astronauts, explorers set up bases and continue space exploration. So that tends to be the main bottleneck is in space exploration is water and fuel. Fuel to get off the planet and water to sustain us once we get off the planet.
Gotcha. So one of the ways that I read about was collecting it and then just manually collecting it and using some form of heat, whether that be heat collected through solar panels or some other source to heat up the water or heat up the ice and turn it into water.
Yes, I know a couple different ways of doing that. When I was researching this, I read some articles about they're designing drill bits that when they drill into an asteroid or a planet or a moon, that it also heats what it's drilling into, and it turns that ice into vapor, and the vapor just rises up, and they can recollect it through condensation and condensation, which is quite effective method. And going back to what you said about using light rays and lasers, they're using the sun in quite a bit of different forms. Not only are they using it to simply melt ice off asteroids and moons to collect water, but they're actually starting to use, I don't know if you came across this, they're starting to use sun as concentrated beams to drill into space equipment, using the sun rays, reflecting it, and beaming it into an asteroid to mine it and drill it without actually using physical bits.
Yeah, I read about that, and I think what one of the downsides to that they're talking about is the actual collection of once you start drilling into it, because you need to let that light in through something that it's hard to collect all of the vapor and you lose some of it.
Yeah, I don't know if you came across this, but I saw one company, they were doing a proposal of almost like capturing an asteroid in a bag, I guess is the best way I could describe it. It would be a probe that would open up, collapse around an asteroid, and slowly correct its spinning orientation to be neutral, and then begin drilling or mining into it, and anything debris that would come off would be trapped in the bag, which they could capture and use. I don't know if you came across that.
No, I didn't read anything about that, but that's a pretty good idea. Had to be a pretty decent sized bag.
Yeah, and hopefully pretty strong too, because staying on the asteroids and debris, one of my biggest concerns when researching this topic was simply the debris caused by mining. Because currently around Earth, we have hundreds, if not thousands, of space debris, which makes it harder to leave Earth all the time. And simply a small little piece traveling thousands of miles an hour around the Earth can do significant damage. So moving forward in humanity's time frame, I'm worried about mining in space, that if there's accidents, it might send rocks going off in different directions, may make it hazardous to mine in space for other people. Simply having dust and other rocks just floating around, untracked, unmarked, going hundreds and thousands of miles an hour.
Yeah, and that's one of the main things I saw too. A lot of the companies were thinking of the easiest way to do it would be to set up some kind of station to harvest asteroids. We just have some kind of station in the Earth's orbit and then somehow direct asteroids to our orbit. And if we had a lot of people doing that, we're just sending a lot of space junk at us or at the moon, wherever we choose to set up those processing centers.
Yeah, definitely. See, I when reading across that, the same thing you came across, I came up with a really crazy idea, and I want to run it by you. I wonder if it's feasible or if it's smart to simply collect asteroids and crash them into a planet. So we would have a sacrificial planet, say Venus or Mars, or have like a moon or some celestial body big enough for us where it has some gravity and some atmosphere so it could break up the meteors, and just send a bunch of meteors and asteroids into a planet. As they come crashing down, they break up, which makes the particles easier to, I would guess, mine, because they're all broken up and on the surface. But we don't have to deal with the problem of having space debris caused by mining. What do you think about that idea?
I also thought of that, but I didn't see anyone else saying anything like that, so I assumed there was some reason that I was missing of why that would be a bad idea.
I'm so happy we're friends. I'm so happy we came up with the same idea. Yeah, as an engineer, I can't see why that's a problem. I mean, you'd have to make stronger equipment to deal with the gravity, but it seems like do one hard step first and save yourself 5 hard steps later.
Yeah, and like you said, it helped break it up. The other thing that I came across is a lot of these asteroids aren't completely one giant chunk of rock. It's just because there's no gravity pulling everything which way, that it's just the only thing to grab onto is other rocks. So they're all smaller chunks. So I didn't know if those smaller chunks wouldn't be able, they'd all get broken up in another planet's atmosphere. But if you landed somewhere with little to no atmosphere, I wouldn't think that would be an issue.
Yeah, I was thinking the same thing. Yeah, you could probably you'd lose some product by the atmosphere burning it up and melting it away, but if you had, like you said, a planet or celestial body with little to no atmosphere, I can't see why you can't collect every small piece, or at least collect much more of it. Which brings me to another train of thought. The different ways people are trying to attach to asteroids and moons. I mainly want to focus on asteroids a little bit before we switch to planets. But to me, asteroids, it seems like it's the harder thing to mine, but it's also the easiest thing to mine once we've landed it, if that makes sense.
Yeah, I mean, I think the hard part about asteroids is, the moon, it's pretty predictable where it's going to be, and it's got a lot of places to land. Whereas an asteroid, you're just kind of going to have to match its speed in direction.
Yes. Definitely the movement to me is the most scariest part. Trying to hit a moving target with $1 million equipment makes me a little bit nervous to do that.
Yeah, I mean, if Bruce Willis could barely do it in Armageddon, I don't know how trained astronauts are supposed to do it.
Armageddon? No, you're supposed to do Space Cowboys. That's such a better movie.
Don't disrespect Bruce Willis again.
Clint Eastwood. I'm sorry, Clint Eastwood. Tommy Lee Jones.
All right, agree to disagree.
I'm not saying that's not a good movie. I'm just saying, if I had to choose, I know what I would choose. But anyhow, going back to asteroids, a lot of them to me were just simply trying to land and use the gravity. I didn't see a lot of mounting equipment when researching this. I couldn't really tell if they were simply harpooning them, if they were putting in spikes in them, or simply just having the gravitational force being the only thing to keep them on asteroids.
Yeah, so I read a little bit about that, and it seems like harpooning would be one of the better ones. The hard part about that is finding an asteroid with material that we can harpoon, something not too tough. They're thinking probably like an ice asteroid composed of ice would be an easier one to harpoon compared to any metal type asteroid.
So like a C-type asteroid?
Yes, that's the word I'm looking for.
Okay. For those listening, they kind of classify asteroids into 3 different types. C-type being the softest of the asteroids, followed by, I think C-types, if I'm not mistaken, have silica, almost like clay material on them. Not quite sure. I know M-types are mainly metal types that have like hard metals like tungsten and germanium, maybe, or rubidium. Not quite sure. And then there's a third type, which I can't quite remember, which is more softer metals like gold. Both all very valuable, but asteroids tend to be broken up planets or planets that never formed. So all the material that was going to be on a planet is there, and they tend to segregate and clump together. So when you come across an asteroid that has has gold, it has lots of gold on it. That's why some of these asteroids are worth so much money. And that's why a lot of people say the first trillionaire individual will be a miner in space.
Yeah, so I'll read you the definition of the different types of asteroids from the book Deep Space Commodities by Tom James. So S-type, these asteroids carry lesser quantities of water but appear more striking because they comprise various metals, including nickel, cobalt, and more valuable materials such as gold, platinum, and rhodium. A minor 10-meter S-type asteroid contains about 650,000 kilograms of metal with 150 kilograms in the form of rare materials like platinum and gold.
That's so much.
Then C-types, these are the most common type of asteroid and comprise more than 75% of known asteroids. They also have a high abundance of water, which is not currently of use for mining, but could be used in an exploration effort beyond the asteroid. Mission costs could be reduced by using the available water from the asteroid. C-type asteroids also have a lot of organic carbon, phosphorus, and other key ingredients for fertilizer, which could be used to grow food. Finally, M-type, these asteroids comprise nickel and iron, but are the least abundant. A very small percentage of asteroids fall in this category, and it's mostly used for rare materials and precious metals.
Well, going back to crashing asteroids into a planet, sounds like send some of those fertilizer asteroids into a planet and see what happens. Send some water, phosphorus, and magnesium and see what happens.
That sounds like a topic for a whole nother podcast, but that would be crazy. We just flooded Mars and made a water world.
I mean, yeah, why not? I mean, a big thing in space, which I don't know if a lot of people know, is freezing cold and freezing hot at the same time. Simply being in the shadow and devoid of sunlight in there, you can drop to, I don't know, a couple hundred below freezing in Celsius. And then when you're in the sun, I think it gets up to like 300 degrees Celsius or even higher, something ridiculous like 300 degrees Kelvin. I can't quite remember the unit, but the difference between being in the sun and the shadows is enormous. And that's another big concern about mining in space, is simply can the equipment maintain and survive the harshness of space. I actually want to tell a little story that I heard about from an astronaut when he did a spacewalk not too long ago, if I'm not mistaken. I think it was less than 5 years ago. He was doing a spacewalk and he had to plug in a piece of equipment. But because he was trying to put a plug in on the outside of the space station, it was too cold, so the metal shrunk and the plug wouldn't fit. So instead of, not being able to do it, because I believe it was pretty critical to the International Space Station, he simply covered the male plug with his hand to keep in the shadow and waited for the sun to come around to heat up the female plug section so it would expand. And the temperatures within seconds were so different that the female plug expanded big enough to take in the male plug, and the mission was completed.
Man, that's pretty ingenious. Yeah, that's a pretty crazy range of temperatures. I mean, you'd have to build, make sure it's going to work in the craziest environments on Earth before you send it into space.
Yeah, even then, I don't know if it's enough, because in space, there's a lot of radiation, and I don't think we have anything quite like that on Earth. To connect the two together, another reason why water is so valuable in space is because it's dense. For those who don't know, you can I'm not completely sure, but water's density allows it to block some radiation that comes out from space. So simply having abundance of water could help protect life forms in space from becoming dead from radiation poisoning or gamma rays.
So you'd use water almost like a kind of a lead shield on the outside to stop radiation from getting into wherever humans are.
Yes, something like that. I also know having high amounts of water in your system, as an astronaut, is extremely important to prevent exposed radiation, because a lot of people forget is there's no atmosphere, there's no magnetic protection from a planet, so the radiation just bombards the ship, and you can easily die from that if you're not careful or you're exposed too long. Do you remember what the longest time in space is? It like a year or so?
No, I'm not sure. I could look it up though.
Because as we more explore into space, the more and more possibility of people will live in space for possibly in the next couple centuries for the rest of their lives. From what I see is the longest space flight by Valery Polyvok from 1994 to 1995, 437.7 days. That's a long time to be in space.
Yeah, that's a long time to be away from Earth and everyone.
Since we are talking about some of the dangers of asteroids, tell me what you came across for mining in space.
Of the dangers of it?
Yeah, like sun rays, radiation, rogue planets, asteroids. What do you know about the dangers of space?
Well, I just know the actual mining process. Sometimes there's gas in where you're drilling that could change. Like if you're drilling through metal and all of a sudden you hit a gas pocket, it could cause some sort of explosion or something. As well as, like you mentioned previously, there's just a lot of radiation in space, which isn't good for most things.
You don't want a small dose of radiation to turn you into the Hulk, Nick?
I think it'd take more than a small dose of radiation to turn me into the Hulk.
I feel like a kid researching mining in space. Just the possibilities seem endless. Just all the places we can explore, all the new technology that'll be made. It feels like we're living in a science fiction world.
Yeah, definitely. And just reading and just thinking about once we have all these inputs, all these materials, just what we can do with them is going to be pretty crazy. And it's one of those things where we can kind of predict where we think it's going to go, but you just never know with innovation like this what's going to happen and what's going to be what's going to fall short and what's going to exceed all of our expectations. It could go any direction.
Yes, and I don't know if you came across it too, but when researching this, there was a great debate on whether we even allow the resources mined in space to come back to Earth.
Yeah, that I read about that, and I thought that was crazy. Just because, say you brought the amount of gold from one asteroid back into the Earth's brought it back into Earth and put it in the economy, it would just completely destroy the value of gold and just completely change the economy of the Earth. I mean, it seems like the most logical thing to do would be to have a space and an Earth economy, because the amount of materials on Earth is so limited compared to what we have in space that you could just shrink the market or destroy the market with one asteroid, and then you have to regulate people bringing materials back. And it seems like the biggest factor is the cost of bringing that amount of material back to Earth. Is you wouldn't create such a huge profit, but at some point someone is going to do it.
Yeah, I'm very happy you brought up all those points. I think the right solution is to have a dual market system of space versus planetary, because like you said, you could destroy a market with one asteroid, which is crazy to think about, that one asteroid could completely ruin the cost of gold or platinum for the entire Earth.
Yeah, and the other thing too is, say once you have, I mean, the space economy is crazy, because once you actually have a colony on the moon or a regular population that lives in space, you can't pay them in Earth dollars because it won't have any meaning. You're not going to pay other companies in Earth dollars if they're like based out of live up in space. So you have to just trade materials almost like a barter system. I mean, it's essentially, it is a whole new frontier. I mean, it's basically, you're going to be just like in Star Wars, you're in the Outer Rim trying to buy some parts from Watto, and Republic credits aren't good there.
I mean, it's not wrong. It is going to be very interesting, though. What will we need from Earth to sustain life in space? Like, to me, I'm thinking like certain minerals, like fertilizers, seeds, plants. Like, imagine farmers selling their extra seeds to go to space in return for pounds of gold.
Yeah, well, that's crazy, because just you would be able to breed. I mean, companies are going to start trying to produce plants that respond well in low gravity environments, and it's going to, whole new industry is going to open up. I mean, just so much industry is going to open up on Earth in support of space exploration. I mean, it's going to be crazy.
Yeah, it's a whole system of sending someone to space, supporting them in space, sending mining equipment to space, getting the mining equipment to an asteroid, mining the asteroid, getting the parts back, getting the equipment back, processing equipment. It's just a stages upon stages of equipment and steps needed. It sounds like a never-ending market and never-ending economy of planets and asteroids and moons to explore.
Yeah, I mean, we are making it sound all really close. I mean, asteroids, I think it's important to talk about actually how far away some of these even near Earth asteroids are, and how long it would take to get there. And say we wanted to bring in the moon to get it back. I mean, it's how far is like even a close one? There's one coming close to us in 2022 that they're going to try and move away, but even that's still going to be a ways away from the Earth.
Yeah, for those listening, most asteroids are in the asteroid belt, which is between Mars and Jupiter, which I believe in the closest flight pattern with a full burn takes, like, with current technology, like 3-ish years to get to, just to get to. And that's one ship. You're going to need a fleet of ships or a fleet of autonomous robots to get there, mine everything, and then come back. So simply mining one asteroid would probably take, right now with current technology, 12 years, I'm guessing, to mine. That's saying if we've already had the equipment ready to go. So the technology is a little bit off, but I think in the next 30 years or less, we'll be sending equipment and probes to other moons and asteroids quite soon. We've already started doing it with some asteroids. We recently just sent a new rover to Mars. So our feet are definitely wet in space travel, and we're getting a little deeper into the water. But like Nick said, these distances we're talking to are hundreds of thousands of miles away, and to get there, you have to overcome Earth's gravity to get there.
Yeah, I mean, there's 6 categories of costs that you have to consider to mine an asteroid, and your first cost obviously is your research and development cost, and that's the phase we're in now. Then you have your exploration and prospecting cost, and that's basically figuring out, an asteroid, like we found it. Now, what is it composed of, and what material is on it and what's the best way to mine that material. And then you have your construction and infrastructure development costs. So that's like we talked about our processing plants of once we have the asteroid and we have the ore, how do we convert it into something useful? Then you have your just operational engineering costs, and then your environmental cost, and the cost we're talking about now is your time cost. So how much money do we have to pay now, and what are we going to get in return then? And one of the problems is it's such a huge time cost that a company has to have a pretty big capital now for it to pay off in the future.
Oh, absolutely. That's why I'm kind of happy NASA currently is kind of spreading its wings and letting private companies help with NASA and space exploration, or a lot more private companies entering the space exploration business. Because I think that having that kind of competition and different industries, and you don't have to be super big and super well funded. You still have to be obviously funded quite well to develop space equipment, but since it's becoming more backyard science and more people are able to do it, it's definitely increasing the time frame what we're doing, but it's still a ridiculous time frame, which is why I believe everything Elon Musk is doing with reusable rockets for SpaceX is extremely impressive. Simply having rockets where you can reuse them and save hundreds of thousands of dollars on rockets just to relaunch them back into space is so amazing, and shortening that time frame by quite a bit.
Yeah, I didn't realize just what the game changer a reusable rocket was in terms of cost. But if you think about it, having to build a whole new rocket, I mean, we learned the hard way, the United States did, of how buying cheaper materials and even one little thing out of touch can be a disaster. But if you use something and you know what goes into it and you can reuse it, that's like so much cost is cut down there, and it makes it so much more accessible.
Yeah. The amount of businesses and industries that are going to form or be replaced by mining in space is, I don't know if they're even countable. Yeah, I mean, you got everything from there. I don't know if you came across this when researching, is there's already universities offering programs and degrees for mining in space in the United States.
Yeah, I did see that, and that blew my mind. I mean, that's crazy, but that would have been crazy interesting. But I mean, we need to
kind of just want to sit in one of those classes just to know a little bit what they're talking about, or like have they online classes or something like that. Because I want to take one of those. That sounds straight out of Star Wars. I'm in. Send me there.
Yeah, well, hopefully it doesn't devolve into mining spice in the Kessel spice mines. But yeah, I'd love to sit in one of those classes.
You're such a Star Wars nerd, and I love it.
It's how every American got into space, isn't it? Love of Star Wars.
Oh, I was a Stargate kid. I don't know if you ever saw that show.
Nope, get out of here.
Oh no, Sci-Fi Channel, man. Stargate SG-1? No. Okay. Going back to the economics of having entire processing plants in space to make materials to keep them in space. It sounds like as we leave Earth, we're becoming more renewable energy, or more renewable supplies in space. Because could you imagine going into space, mining a asteroid, taking that asteroid, processing it, plugging it into a 3D printer, using that 3D printer to print a part to help you mine the next asteroid?
Yeah, I mean, it's just a more technological version of humans moving west across the U.S. I mean, it's Manifest Destiny 2.0. We're turning untamed wilderness into something humans can use and benefit from.
Absolutely. The knowledge that we'll gather from simply just doing it, because for me, I think humans learn best by doing. I think that's how most humans throughout history have made big leaps and bounds, by simply doing something as an experiment or trying. But all the science that's going to come with it, of someone innovating and coming up with a new part or a new process or new fields, or coming across different ways to do things that we haven't even dreamed of yet. It excites me. It excites me that we have such optimism every time we look into the stars, and they're almost in our hands.
Yeah, and that's a good point you bring up that I want to expand upon for people who don't think that spending all this money to go into space has a benefit to them. There's so much technology that we develop for space that we use today. I mean, that's a lot of solar panel technology came from going into space, and so many other materials and projects that NASA and other space agencies created to help with space travel that we use today. In like satellites, all of that came from some kind of space activity. And so even if we don't see a direct link, that you don't benefit from this, humans all over the globe are benefiting from our reaching for the stars to try and continue to move into space and start processing that.
To add on to that, like, I don't know what you know if you know what origami engineering is, but origami engineering is coming up with a pattern or collapsible item that will expand into the shape you need it to be. It's been done for centuries, but really got rejuvenized by the space industry for having solar panels fit compactly into a space engine, expand out when it got launched into space so it can collect the most sunlight possible. Well, that origami engineering is back here on Earth is now expanding because it got brought back to life, and it's making things smaller that would normally be heavier and clunky to use, but smaller and able to expand and contrast and be shrunken down for everyday use, which is, like what Nick was saying, the innovations that are made in the space race and simply exploring and coming up with science comes to your backyard. I imagine we wouldn't have the cell phone right now, or a smartphone, or a computer, or a laptop, or pretty much any device with a microchip if it wasn't for exploration of space.
Yeah, and we're still at the beginning, so who knows what's about to come.
Going back to asteroid mining, because I'm happy you came up with the idea of crashing asteroids into a planet too. As an engineer, I like problem solving, and I was wondering, do you know what the process of a water jet cutter is?
I believe so. Just concentrated water shot out that uses basically an accelerated erosion process to dig through a material.
Pretty close. So Nick was pretty much right, except they add usually an abrasive into it, and the water pushes the abrasive, which then cuts it. I was wondering, can we do the same thing with asteroid mining? Could we collect some of that dust as a byproduct that's going to happen from breaking and mining an asteroid, collect that dust, collect the frozen water, and then use that to mine other asteroids? Could we make a space water jet to cut open asteroids?
So I guess what I was thinking, one of the issues with that would be you'd have to do it, add some of the water to keep it from freezing immediately.
Ooh, I did not think of that. Well, if you have a tank, you could simply just use coils and just run a current through them to heat them up, or have them like in a solar tank when you need to use them. Maybe it's like a two-part step. Like first you mine everything. When it's get low on resources, it goes back, delivers everything it is, filters out the large particles of dust to only have the particles of dust that you need. Of course, then it goes to that all the dust collected won't be used. You're going to need a very abrasive molecule to do that. I don't know. It was just a backyard idea that I was tossing out there.
Yeah, so one of the things I thought initially would be the easiest, starting out at the very beginning of asteroid mining would just be a magnetic rake. Just go over the surface of the asteroid and collect all the loose pieces. Very simple. You won't get as much material. You won't be able to collect the whole thing, but from starting out, it'd probably be the simplest. You just get all that dust and a few bigger pieces to bring back to the processor. If it's a big enough asteroid, I don't know what our capacity is going to be to store ore anyway. And that's probably, at least for a smaller research mission, probably the most feasible from the beginning of the process.
So for space mining, you just simply want to mine iron, nickel, and cobalt then?
Yeah, I mean, at first we have to start somewhere. I mean, so right now we're the OSIRIS-REx, which is going to land on the asteroid. It wouldn't be too hard to just do kind of a similar thing and bring back that material, and then you could you examine that material, whatever it picks up, to confirm that that's what's on that asteroid. Because a lot of one of the bigger pieces is figuring out what exactly type of asteroid and what's on it. If you don't want to send the wrong equipment to the wrong asteroid, because different asteroids are going to require a different process to remove whatever material you want.
So I kind of disagree with that statement. I believe that the future for this might be too far, and we might be talking about different time frames. But for asteroids, simply sending drones and autonomous robots to scan, because we don't have to land on the asteroid to figure out what it's made of. And the main thing that I disagree with is going after iron, nickel, and cobalt, because those three materials are quite abundant here on Earth. I imagine is the first thing humans are going to want and need is platinum and gold, because they're non-corrosive. They do well in space because they can handle the radiation, and they're quite useful for circuitry and other space mechanical parts. So I don't know if a electromagnetic collection would be the best idea. I think a simple landing and doing small drills, maybe 12 feet into the surface just to collect samples, is the best, or simply just collect small asteroids that we could fit into a station and drop them off at a base somewhere, I think would be the first steps. Do you want to defend or rebuttal your statement?
No, I mean, that was just what I thought would be initially a cheap, cost-effective way to mine material. What do you think about some kind of underground, almost like a mole, a robotic mole that gets onto the asteroid and starts digging and collecting materials?
I think that's an ingenious idea. Simply just underground in general for everything space, because it will protect you from dangers, but simply having a robot or machine to go under the ground, I think, limits what your losses are. Products aren't floating away, because you got to remember that everything you mine can just, if you don't collect it right, will just chip off and fly off into space, which is going to cause a bunch of different problems. But I love that underground idea. I think that's an ingenious idea.
Yeah, like you said, you don't have any problem collecting the material because there's only one way it can go, and you can filter out materials you don't want, some maybe, but it's pretty contained. The problem with that would just be that that's a lot tougher equipment, so it's going to be a lot stronger than some other kinds of mining.
Yes, and another thing is you got to be careful of, we don't know how the asteroid is composed, so it might crack on you, and hopefully everything would be autonomous and you wouldn't have a human driver, because the last thing we would want is someone using a machinery and all of a sudden the asteroid cracks in half. I have no idea what would happen. Like, I think that's unpredictable. You need a bunch of supercomputers to figure out what would happen then.
Yeah, well, I can tell you, it sounds like you're writing the plot of a Tom Cruise movie right now.
I can do that. Give me a couple hours. I'll write a script for you. But I'm glad we're talking about problems, because a problem I didn't really come across of, which I'm very curious about, is astrology here on Earth, how much it would be negatively, not positively, but negatively affected by mining in space. For those who don't know, a lot of telescopes here on Earth, deep sea telescopes, use different types of wave functions to measure, to look, to get data from space. And I'm thinking, with all that mining equipment, all that dust being collected, all this processes, all the engines firing off, I'm wondering what kind of background noise that will make for telescopes here on Earth, and how much that would hurt astrology on Earth, at least deep space exploration. What are your thoughts on that?
Well, I think, with this advance in leaving Earth's atmosphere and making it more and more common, that most of our astrology would be moved off the Earth, and that we'd have more telescopes orbiting the Earth, so we don't get interference from the atmosphere or anything like that. So I don't think it's going to be as big of an issue, but as more space exploration takes place, yeah, there's going to be a lot more human traffic, radio traffic, communication, actual vehicles that people are picking up, that's going to cause interference with that kind of stuff. I think it'll only enhance our view of the atmosphere, but I think it'll hurt what we hear from space.
I agree with that Completely agree with that. I'm not sure if humanity's ready for rules and regulations for space mining. I think, to be honest with you, I think the best way to have it off is let it be the Wild West for a little bit. People try to figure out what works and doesn't work before we start making, like, hey, you can't use this radio frequency out here in space, or you have to mine it this way, because this is such uncharted territory that, again, I think doing is the only way we're going to learn the best ways to do things for mining in space.
Yeah, I do want to bring up, one point. Are you familiar with the tragedy of the commons?
I am not.
Okay, so it's a big thing in natural resources. It's a pretty simple concept. So the tragedy of the commons talks about what happens when multiple people want to use one piece of land, basically. So imagine a field, and you have 4 farmers, and the field can support 20 cows. So naturally, each farmer is going to put in 5 cows. They're just going to split it evenly because they agreed to it. Well, one day, one of the farmers like, well, I'm just going to run more cows on it, and they don't agree to it, but it's not governed by anything, so they run all the cows on it, and pretty soon the field can't support any more cows, and all the cows die. So it's basically just a story about sharing resources. It's a natural, like forestry, grazing. It's just about land management. But I think it's important that we have something set up that limits who, it's not just one person taking all the resources. Like, you can't claim anything. Like, I'm sure you've read all the different stories of people all over the U.S. and the world creating some random religion claiming an asteroid as their own and suing NASA for landing on that asteroid. I mean,
Yeah, I agree with that. I believe there's got to be some rules and regulation, but I don't think I completely agree with what you're saying about managing it and trying to figure out the best way to do it. But I still believe that we're not going to know until we get there, if that makes sense.
no, I completely agree. Don't get me wrong. I'm not a huge fan of government regulation at all. I just don't want to. I don't want our progress to be hindered by well-meaning people that end up hurting our overall objective of exploration. But I also don't want all of our resources to be consumed completely. I mean, I've heard of there's a lot of different people have a lot of different ideas about how to regulate space. I've even heard of some people wanting to create wilderness areas where we're not allowed to harvest asteroids, and just so that we have those resources if we need them, or if there's some part of ecosystem we don't yet understand.
I did not come across that. That is extremely fascinating. But yeah, I agree. I don't think mining in space should be monopolized, and I also don't believe some random crazy person with no background should be able to just launch a rocket like to start mining in space, even if they get the permits. Should definitely be a middle ground in between those two, at least ideally.
Yeah, I kind of compared it to offshore drilling. I don't know how much background you have in that, but I'm sure you heard that a lot of companies will fly the flag of a nation that has little to no regulations on offshore drilling, so they don't have to follow like the United States' stricter OSHA regulations and all that kind of stuff, so that they can create more of a profit. And I get that, but I don't want that to be something in space where people are cutting corners just to create a profit. I mean, you do that in the earth, and that's how the oil spill in the Gulf happened, and you do that in space, and that's how all those people die. There needs to be some kind of faith.
Agreed. From what I could come up through reading space law is each spacecraft or space mission, I'm not quite sure if there was a difference or they're the same thing, is subjugated to the law that they're coming from the country they're coming from. So kind of like ships. Like if you sail the ship from Mexico, you're technically underneath Mexican law on that ship. And I think they're applying the same logic to spacecrafts currently. At least that's what I gathered. I could be wrong on that, but I'm not. I believe it's kind of like ships in an ocean is what we're using laws for space.
Yeah, that's kind of what I saw as well. I did see that Luxembourg is one of the most progressive countries for space law, and a lot of startups are moving there because of their willingness to work with these companies and grant them rights to do pretty much whatever they want.
Yeah, I saw that too. They were offering like a 220 million euro finder's fee or reward for coming up with the best way or having a successful space launch for space mining, which is so weird to think about that we're having competitions to try to do it. It's literally just around the corner.
Yeah, and like we talked about how we don't want it overregulated. I think one of Luxembourg's big attractions is there's not that much regulation, which promotes growth, and the more regulation is going to hinder. You don't want it to be so unregulated, but at the same time, we don't know enough to completely regulate it, which is what Mike is saying, that it's a good stepping stone once we see kind of how the space economy is going to work, how space mining is going to work. We can go from there, but we don't want to jump the gun.
Yes, this is a completely different biome. Now, we may know things about this biome, but again, like we just looked up, the longest person was 400 plus days in space, not that much longer. That's a very short time for a human life. It's a little over a year, but a lifetime in space, or everything that will come to space, which brings to the factor of what happens if we don't send humans to space. We just make it all autonomous, all robots, which I have some concerns and optimistics for. What's your thought process on that, Nick?
I think from what we know right now, that might make more sense, but I think there's no way humanity is not going to try and create a settlement on the moon or Mars. I mean, you can't.
Oh, sign me up. I'll gladly die on the Mars.
Oh man, I will be on that flight too, and I'm just thinking of ways how I can smuggle a lever action onto that flight, because yeah, I'm my Henry 4570, and I'm gonna explore the last frontier.
That's a good way. That's a good life. I would say I'll gladly join you on that adventure, my friend. But for me, going back a little bit back on topic, is the automation is the delay, the radio and the signal delay of doing these. These would all have to be autonomous, I believe, in order to successfully work. Because what's the delay from Earth to Mars? It's like, what, 14 minutes?
Yeah, I think the moon is 6 minutes.
And now we're talking about going to the asteroid belt, which is past Mars and closer to Jupiter. Like, that's got to be nearly an hour, I would imagine, of delay. There's no way a human could pilot and control that. So I imagine everything's going to have to be autonomous, so have a swarm of drones and robots doing all the mining for us.
Yeah, I imagine it'd be semi-autonomous, and you would have, like you're saying, a swarm, but they would all be sending videos back to Earth, and you'd have someone watching them, maybe offset, so that they can make decisions in almost real time. I mean, so if it's one guy making a decision every hour, that's not a lot. But if you have a lot of drones, and one guy making decisions every couple minutes after reviewing the footage, it might make more sense. Or you at least going to need some kind of human interaction for troubleshooting and problems that arise. I mean, you don't know what you don't know. We're not going to be able to program a drone to do all of this right off the bat. We're going to need some kind of human control, or be able to take over if the programming fails in whatever task.
Oh, I completely agree. That's why I think having bases would be the best idea. Like going back to the beginning of the podcast, of having a base on the moon or having a base on Mars, or an ideally situation, Europa, I believe, is supposed to be completely like frozen water, and it's a moon of Jupiter. So collect a bunch of water from there. Have autonomous robots collect metals and materials from the asteroid belt in between Europa and Mars. Have a base on Mars where you could process the materials, such as the metals, melting it down to ignites, and et cetera, and then have the water and metals go to the moon and whatever, and like create more robots, or just simply back on Mars, because perhaps Mars is big enough to handle that.
Yeah, and like one of the things that I was reading is that the first thing we would design in space would basically just be a gas station.
Yeah. Water is king in space. Not simply just to drink and grow plants, but to split into hydrogen and oxygen. Like, that is the main mode of transportation.
Yeah,
Can you imagine having a bunch of gas stations in space? Just how weird that would be to see.
yeah. I think, I mean, even if they had no affiliation, how funny would it be to just have like a Circle K logo on that gas station?
Oh, I would lose it. I would. That would be so funny. Oh, that brings an interesting point. What about sponsorships? Like, there are big companies that donate money to athletes so they can perform better and wear their equipment, et cetera, et cetera. Do you think the same thing could happen to astronauts, like, or companies mining in space? So have a mining company supported by a university, or a mining company supported not just by a government but a business empire, like, say this metal is used in your car is brought to you by Mining in Space 2.0, and it's also used in your Walmart products. Do you think having private investors for a private company is possible for this space exploration?
Yeah, I think there's marketing executives at Red Bull who are lining up right now to do that very thing, if I had to guess.
I mean, I'll gladly wear Red Bull space suit. I'll gladly wear that red and blue on into space.
No, I think that it would be, there's so much money that needs to go into this. You'd be a fool to turn away money from anyone who wants to help you carry it out.
Completely agree. The upfront costs are very high, but the rewards are so vast. It's unlimited money pretty much in space. And since we were talking about it a little bit, I wanted to switch back to planets. We talked about asteroids a little bit. We talked about moons a little bit. We should talk a little bit about mining planets. I think mining a planet is actually going to be a lot harder than mining an asteroid, and I think we should probably not try to mine planets unless we're going to crash asteroids into the planet. What's your thought and process on that?
I figured that mining a planet or a moon would be easier. You're going to have more gravity. You know, the moon's so much closer. I mean, I think that would be the first logical step.
Well, I'm gonna say I really don't think we should mine the moon. I think the moon should kind of be off limits because how important it is to the Earth's ecosystem and life on Earth. I kind of think the moon should be no more than a base and not used for mining. But to talk about your gravity point, I think gravity is more of a hindrance because if you look here on Earth, you have to search and hire experts to figure out where the resources are. With asteroids, you can identify what type they are and you already know what's in them, or at least have an idea of what's in them. So I think no gravity and having an idea where the material is, I think is a lot better than mining on a planet. But having gravity and having an atmosphere makes it safer for the machinery because nothing crashes into it. That's my thoughts on, like, at least how I thought about it.
Yeah, I mean, I think just that atmosphere, I mean, for Mars, just that little atmosphere and to gain from that. I mean, imagine we launch a drone to go mine some asteroid and halfway through just gets destroyed by another piece of space junk we didn't see. I mean, that whole company's going under initially. If that's their first mission, that's it.
Yeah, that is definitely a gamble. The early days is going, like I said, going to be the Wild West of space debris, rogue planets, rogue asteroids. Maybe both. Maybe we hedge our bets and do both. I don't know if when researching this, you came across, NASA had a competition maybe 5-6 years ago about building buildings on Mars. And the competition winners used a 3D printer to collect the surface of Mars material and process that into a material that can be 3D printed and it can print and be able to make a 3D structure. I think that's a good step because you could perhaps 3D print a dome and start doing strip mining underneath the dome. That seems like a very viable solution to me.
Yeah, I mean, another thing I read was about how it wouldn't be that difficult to turn moon or Martian soil into something that could actually grow plants. And so I think creating some kind of dome would be a first step. I mean, almost a greenhouse.
Oh, yeah. I mean, that's a whole another podcast talking about living on another planet indefinitely or completely changing a planet to support life. But perhaps space mining is the first step in order to make that happen. Because to me personally, we need to become an interplanetary species. We are simply growing too high in population to stay on one planet, and perhaps mining in space will open the doors to spread out throughout the solar systems.
Yeah, I mean, that's probably, I can't wait. I mean, it's how long, I mean, every human, even if they don't think about it, would love to be an interplanet species. I mean, that's, I don't know what it is that makes us want to continue building and exploring, but it's something that's in our DNA. And I'm assuming it's not just Americans, it's every single human. I mean, we had a whole race Cold War over this with Russia, and we're still, once we won, we kind of stopped our space exploration, but now I feel like everyone's getting back into it. We have all this technology, and we think we can really do it, and I think it's, there's no way to stop it now. It's a fever that is caught on with a lot of people, that we are going to become a multi-planet species.
Yes. I'll get a little off topic. I love how you said we won the space race, even though Russia had like first object sent into space, first life form sent into space, first human sent into space, first human to come back successfully in space, and all America did was the first man into space to land on the moon and come back.
If you run a marathon and you're the fastest out of 25 miles, do you still win?
All right, touche. I like that. I've never heard that analogy. I like that analogy.
Oh, I mean, it's the space race isn't over, but I think the U.S. is.
Personally, I don't want it to be ever over. I think the competition and the idea of country versus country, business versus business, trying to compete to make the best, like Jeff Bezos and Elon Musk, how they both have their own space companies. I imagine having that extra competition puts a little pep in their step to make the best rockets, to make it the most efficient, to make it better.
Yeah, I mean, competition is what motivates a lot of people, and sometimes I think that the reason we're going back into space is just because other countries started doing it, and America's not one to fall behind of other countries. We're like, oh, you're doing that? Well, we're going to do it better.
The good old American way.
Yep. Anyway, but yeah, so you're thinking that mining on a planet would be the most logical. What techniques do you think would be the best? Like you mentioned surface strip mine. You think that would be the most?
I think it depends on what we want to do with celestial body. Like asteroid, we can just break up. Moon, I think it depends on the moon. Like our moon, I don't think we should touch at all mining. I think that should be, like you brought up, have it preserved. Have it a space force preserve, pretty much. Like the moon is just to visit, not to touch. Mars is tricky to me because Mars is the closest planet that's similar to ours that we could possibly turn into to support life. So thinking ahead, maybe we don't want to do strip mining, unless strip mining we can process and keep all that material and mix it in with other material we bring to create it so that the soil is more fertile. So I think the best process is environmental mining, which is kind of taking it careful and only choosing select areas where to mine and kind of keeping it contained and making sure long term that's not going to affect everything or just ruin an ecosystem once we colonize Mars. Now, strip mining would be the easiest and fastest and perhaps the fastest way to get us to Mars, but I'm a bit torn on that. What's your opinion on that?
Well, I think you can draw a lot of similarities between Americans moving west and what's happening now. We were able to take advantage of numerous resources and create a country. However, there's a lot of ecological downsides to that we didn't see, and we still don't fully understand because we didn't have the data beforehand. It's hard to compare to the data that we have now. So I don't think we should rush into this, but at the same time, I don't think it'd be the worst idea to designate one area that, okay, maybe we're going to intensively mine this one spot just to get the resources to carry out all these missions, to research more and understand what we're doing. But then you run into, well, how is it fair that whatever corporation that got to do it or was there first, they're allowed to mine there and we aren't? So, it could go either way, and I don't quite know the right decision. I don't, want to completely just destroy Mars if there's a chance that we could live on it. But it would be, like if we mined it, we could take out all those metals that we need to form soil. We could put what we want to form better producing soil. So it could be our benefit to do that, but I don't think we know enough yet, or I don't know enough yet to make a decision.
Mm-hmm.
So I'm sure someone out there does, but I could go either way.
Kind of combining multiple things you said. I know Mars, no country's allowed to own. So I imagine if we started mining on Mars, it'd be free reign. Like people could just mine whatever they want, which is, I don't think, the best idea. Which I think why, again, asteroid mining is probably better because it's just remove the asteroids. It's not affecting an entire planet. But you did bring an interesting point of rules and regulations for that mining. Like, yes, maybe have it only in a certain area. And maybe that's something we need to discuss as a whole planet. Like, say, get the United Nations involved of, hey, when we do go to Mars, these are the mining zones. Whoever gets there first can have so much zones and they can do whatever they want with them. But all this land is going to be meant for habitat. That's an interesting idea, Nick. I didn't think about that. I'm happy you brought that up, that some company could just dominate a certain area. I imagine it's going to be like when people first discovered oil, where they just kept mining and destroying the environment, trying to find the right spot that had oil, and all of a sudden struck oil. And a lot of people lost their lives and lost their money, lost their businesses because they didn't find the right spot. And it seems like space mining has the opportunity to be the same. It seems like history is repeating itself on a grander scale.
Yeah, well, we were talking about space mining, and I think you're going to have two groups of people up in space at first. You're going to have as well educated astronauts, and I think you're also going to have a bunch of roughnecks who are willing to do the dirty work, who are willing to stay in space for a long time to make a bunch of money. I mean, just like those guys working in North Dakota, that's a tough job, but they get paid really well to work in just terrible cold conditions. That you're going to need people like that up there if you want to do this manually. Now, automation, it's an entirely different thing, but this all stems from some kind of resource background where at some point these resources aren't infinite. And when you're talking about mining a planet, so you're going to have some kind of an agreement about who can do what or where you can do it, because, and then you're going to have to enforce it. I mean, say we become a multi-planet species, the United Nations isn't going to be able to find some company if everyone lives on Mars. So there's going to have to be some other kind of enforcement or something. But
yeah, that's going to be very interesting. Will, say, a company from Britain get charged and fined from Britain, but if Britain's government does it, we'll get fined and charged from the UN. That's a whole can of worms of thought process, which is scary to think about, of the space rules. And of course, if there's going to be space rules, there's going to be space pirates. I want to talk about a little bit is the black market of mining in space, because I believe that will happen. Because could you imagine having an asteroid worth billions of dollars and being told not to bring it to Earth because it would upset the market? I imagine there's going to be people who are going to try to smuggle in mined asteroids and mined resources from space simply to grow rich. And for those listening who haven't thought they've done it, people have stolen space rocks from NASA that are worth, I don't even know how much money, probably tens of thousands of dollars, for greed. And you don't think if you gave someone a chunk of gold and told them they're not allowed to bring it back home to Earth, that they're not going to do it? So we got to come up with regulations for what happens if someone accidentally or purposely brings in a foreign material they weren't supposed to bring in that could change the pricing of the market. Do we send it back to space? Do we store it underground and not use it? What's your thinking on that?
yeah, I have no idea what we're supposed to do with them or even the material. I mean, just imagine someone brought down 1,000 tons of gold. I mean, obviously we're humans, we're going to use it, but you have some, and then what, the government gets it? That doesn't seem fair. I don't just want to give the government free money. But yeah, I highly doubt we'd send it back to space. I'm sure we would use it in components of something. It's just someone's going to have to get that money, because if you just give it away to be used in material, then that company, then they lose, then they basically get all that money. They don't have to pay for that material. So I don't really know how that would work.
Maybe we find middle ground and say someone brought back 50 pounds of gold. That's a ridiculous amount, but just stay with me. If that's illegal gold that wasn't supposed to come back to Earth, that is immediately used to make space equipment to send from Earth into space. That is their only purpose.
Yeah, I think what you're going to run into is everyone's going to want to use that material for, or say 50 pounds, you sell it, and all that, to just put it back into production.
No, not selling it. I'm saying say company A will call illegally smuggled in 50 pounds of gold. I imagine that we'll eventually have an international space committee. That gold is sent to the International Space Committee, which then the gold is solely used to create electronics equipment for space travel, like say public space travel, like so maybe countries can use it so it cheapens their program, or it's it's weird saying that, but a distribution of wealth, which I it's just really weird to say coming out of my mouth, of that material to make it cheaper for other companies to go to space.
Yeah, I think that would be fair. I think it'd be because if you put it back into private space production, you're basically just telling them to bring materials back. But if you brought it back into the government, but I think it would be, if that's something that could potentially really disrupt the world economy, there's one thing that you can pull on is people's tribalism to their country if they're still tied to a country. And what I would say is, say a U.S. astronaut or U.S. private company brings a bunch of gold back, that gold is given to what people would deem a rival country, like China or Japan, given to their program. And China brings back a bunch of gold, it's someone, and there'd have to be some middle party to police everyone coming back down that's not affiliated with either country, but then that gold's given to the U.S. kind of thing.
Maybe the best solution is just to destroy the gold. It sounds weird to think about, but if we can't play nice, no one gets it, maybe mentality. I don't know. It kind of excites me that there's eventually going to be space pirates, but like you said, we're kind of need some rules and regulations before things get too far out of hand and we have no idea what we're doing.
Yeah, especially with something where, the next great weapon might not be a nuclear weapon. It could just be someone brings a ton of gold to Earth and destroys our global economy.
Yes, or simply just drops it. Simply having that much density and weight crashing into the Earth could could destroy the entire planet. Be like another asteroid destroying the dinosaurs. Switching topics a little bit, did you come across any bacteria mining when you were researching?
Not mining specifically for bacteria, but I saw that people had found like frozen.
No. Using bacteria to mine.
Oh, no. I had not seen that. Like some kind of archaea bacteria that survives like crazy extreme conditions here on Earth that just can go through really tough metals and stuff like that.
Exactly. And in fact, if I remember correctly, it was discovered and used about 100 years ago and kind of died off, but it's making a comeback because of space mining, and some companies are trying to use it in mining on Earth, but it is a very real possibility. I believe, in fact, there's actually the possibilities of a space launch happening within the next decade to test a bacteria mining sample on asteroids. So there's two types of bacteria mining. There's bacteria mining that mines the soft material away and leaves nothing but the metals and the harder materials. And then there's bacteria that goes after the metals, eats the metals, uses the metals to keep itself alive, but eventually kind of gives the metals back out in the long run. But it'll just leave the soft material behind. So it is a very possibility that we'll use biotech to mine asteroids in space, or even planets, or because we're using it on our planet currently in some situations.
Yeah, that is pretty crazy. I hadn't read about that, but that's such a good idea, especially with advances in gene editing. We already have bacteria that lives in crazy environments here on Earth that could probably be easily adapted to live in space.
Yes. Do you know what a water bear is?
This is not a SpongeBob reference, is it?
No, but I'm happy you brought that up. No, a water bear is a small little organism that they come in different species, but overall the water it's like grizzly bears, black bears, but water bears are small little organisms that survive extreme environments. In fact, I think some of them we're brought into space, we're exposed to space, and then we're brought back to Earth and we're able to be revived or go back to normal. I imagine if we take those genes and mix it in with the bacteria genes, because a lot of the bacteria that they're thinking about using are quite acidic, where they are a very aggressive bacteria to eat away the metals or eat away the soft materials around the metals. If we can make them survive the cold and the radiation and the heat of the sun, to me that sounds like the easiest for ARTEMIS. Simply have a drone fly, inject some bacteria on that, let the bacteria eat away all the soft material, swoop up, clean up the metal, and then fly off.
Yeah, I mean, that does seem like a pretty good idea. For those of you who don't know that much about a bacteria, so there's two main types of bacteria. There's eubacteria and archaeobacteria. Your eubacteria is your common bacteria that we know about, and your archaeobacteria are bacteria that survive in extreme conditions. Think thermal vents on the ocean, or like gaseous pockets up on Earth, extremely warm, extremely cold places.
Yeah, extreme is a little bit of an understatement. These bacteria can live in mercury lakes. They like you said, the underwater water vents, which are extremely hot, tons of sulfur. Unfortunately, again, I'm not a biologist and I don't know that much about it, but it seems like bacteria mining would be a good process. But again, it goes back to my earlier concern of making sure we don't have space debris. And I still can't figure out the best way to contain the space debris for an asteroid when we're mining it.
Okay, so I know we're currently experimenting with creating our own gravity using some kind of rotating ring. Would it be possible to create our own gravity centered around an asteroid? So while we mine it, we're pulling all that dust and debris back towards the center, and that way it's not escaping.
So if I remember correctly from physics, is that using centrifugal force is the main process behind spinning in space to create artificial gravity. I don't know if that's the best idea with asteroids, because I know for most processes I saw, like capturing them, it was about making sure that they're not spinning, that their orientation is calm and simple. But maybe having it that far into space, it doesn't matter for the debris. Maybe having it that small, it'll just burn up in atmospheres and will collect onto other asteroids, because a lot of asteroids are circling other asteroids, like their own little solar system, because it's the only thing with gravity out there, and it's the only thing they collect to, because they'll eventually, give enough time, collect together and start forming another planet or a larger asteroid. It's for artificial gravity, though, I don't think that's an option.
Okay, well, I have another idea I just thought of. So, I forgot what company it is, but it's launching shoebox-sized satellites pretty much every week out of either Australia or New Zealand. How hard would it be to create just like an army of drones in space around the Earth's atmosphere that all they do is collect space junk and put it in a singular spot and get it out of the way of launches and whatever else is going on to keep our flight paths clear?
Now, are we talking about space debris on Earth, or are we talking about the space debris caused by asteroid mining? Because those are two very different things.
Well, either or. I mean, if we just had a bunch of drones that collected that debris, then we wouldn't have to worry about it flying everywhere. It'd be a contained system. Maybe easier than a real, like you're talking about the bag idea. You know, it might be tough to have some bag large enough that's going to stop not only what's coming out, but what could be coming towards the asteroid.
So, yes and no. I agree with your ARTEMIS pretty much ARTEMIS vacuum cleaners for asteroid mining. For space debris on Earth, it's a little harder because they're traveling with such force. So you're going to have to match the speed they're going at and then slowly decelerate them, which I'm not sure how you would collect them, because there's a lot of small tiny objects, and these small tiny objects I'm not sure if we can calculate. I know most space debris is mapped out around Earth, and for those listening, I highly encourage you to go look at a map of it, because it is scary how cluttering around the Earth it's getting. But for the ARTEMIS robots,
what about, are you familiar with Spaceballs?
Yes.
Giant vacuum cleaner. We turn it from suck to blow.
Actually, yes. That actually is not the worst idea.
Well, I just assumed that would have been the worst idea, but continue.
Maybe we do calculated explosions in space. Now, I know this sounds crazy, but I mean, it's just us shooting the shit. But a lot of this space debris, if it's traveling so fast that if it hits something, it'll just decimate like a space station or satellite.
You had my attention at explosions.
If we destroyed the big stuff, like the big stuff we could probably collect and probably control and probably could recycle and reuse, but the little stuff is the more concerning part to me. If we did control explosions, I'm wondering if we could change the direction of their orbit to make them crash back into the Earth so they could burn up in the atmosphere. I wouldn't want to use it for asteroids because then it would just create a bunch of rocks everywhere and make it crazier. I like your vacuum idea, though. Have literally a vacuum drone where you're mining and just suck everything up while you're mining.
Yeah, but you don't have air. What are you going to use to create that suction?
Well, this might be getting a little too far in the future, but even in a vacuum, there is material. It's called quarks. For those unfamiliar with quarks, it's a subatomic particle that pretty much makes up the entire universe. They're like what make up atoms, I guess is the best way to say it. So even if you have a complete vacuum, quarks, I believe, if I remember my quantum physics, are still there. And I know some people hypothesize we can use them to create energy. And if we can do that, I can't see why we can't use them to somehow suck or form. There's got to be a way. There's got to be a way to suck up the dust.
Yeah, I mean, I think just like anything, we'll start out and it'll be very crude at first, even with all our current technology. We're just going to be able to control the larger debris, but probably once we have a better understanding and better technology, we'll be able to find some way to suck up all that dust and use it, even if we just deposit it somewhere to keep it out of flying around.
What about this? Might go back, this is kind of going back to your artificial gravity. Maybe we do use kind of gravity to help us collect things. We take a asteroid, say what's more dense, gold or platinum? I think gold's more dense. We make a giant ball of gold, so it's super dense. So it would create probably the largest gravitational field if we're in an asteroid belt. And we bring the asteroids to the golden sphere to drill them on there. And maybe the dust from the asteroids would collect on the golden sphere because of the gravity and the distortion of the fabric of space. Does that sound too crazy, or is that just possible?
I think that sounds probably makes the most sense. I mean, we might just be thinking of trying to bring gravity there because that's what we understand, but that makes the most sense to me. Even if a minor gravitational field is going to be better than the absence of gravity.
Yeah. Well, you got me really curious about the vacuum thing. Isn't there a abundance in hydrogen in space?
Yeah.
Could we maybe collect that, compress that, and use that like an air gun to blow the dust into a bag or something like that?
Yeah, I guess so, because you're most likely going to use hydrogen for fuel. You're probably going to have a bit of it, and you could probably use that and have some sort of trap collection device.
The engineer in me is thinking maybe take a soft gasket almost over, like, so say for those at home listening, you have a cup and you drill a hole in the bottom of the cup. Well, that hole will now be where your drill bit is. So when you put the cup down, nothing can bounce out of it. And perhaps we can use the hydrogen, flood that cup so with a gasket, like a rubber gasket at the bottom, so it seals around the jagged surface of the asteroid. So we could push all the dust into whatever we just mined into a container. I think that's a feasible possibility.
Yeah, you're basically just talking about a funnel.
Yes. An asteroid funnel. I like that, Nick. You should coin that up.
Sounds good. I think I'm going to go make my millions.
While Nick goes and makes his millions, I want to thank you all for listening to this episode of Backyard Philosophy. I hope you enjoyed our discussions on space mining, and I assume that we'll be talking more about space mining in the future. But thank you all for listening to our podcast.
Thanks for listening to the Backyard Philosophy Podcast. We rarely finish a podcast without missing a point we wanted to bring up, so let us know what we forgot. And if you have a topic you want us to talk about, let us know at Backyard Philosophy on Instagram and Backyard Philosophy Podcast on Facebook.